Imagine discovering that your entire life, your memories, your relationships, even your consciousness, was just code in an advanced ancestor simulation. How would that change how you live? This isn't about fear, it's about perspective. Whether we're in base reality or not, the simulation hypothesis forces us to confront profound questions about meaning, purpose, and what we consider real. Philosopher Nick Bostrom laid out 3 stark possibilities about our existence, and each one makes you question everything. The first option suggests civilizations might wipe themselves out before developing simulation technology. This connects to the Fermi paradox. If intelligent life is common, why haven't we found any evidence? One answer is the Great Filter, where advanced societies hit some catastrophic barrier. Nuclear war, climate collapse, or artificial intelligence could all be potential filters preventing civilizations from reaching simulation capability. The second possibility is more optimistic but equally unsettling. Advanced civilizations might develop simulation technology but choose not to use it. There could be ethical concerns about creating conscious beings in a digital world. Or perhaps they decide simulations serve no practical purpose. Some might argue running ancestor simulations would consume too many resources, even for an advanced society. Elon Musk has pointed out that if any civilization ever runs simulations, the number of simulated beings would vastly outnumber biological ones, which brings us to the third option. If civilizations don't self-destruct and they do choose to run simulations, the math suggests we're probably in one. Think about the numbers. If one advanced civilization runs just a few simulations with billions of conscious beings, simulated minds would quickly outnumber biological ones. The odds tilt heavily toward us being part of that simulation, rather than the original civilization. Musk puts the chance we're in base reality at 1 in billions. This trilemma forces us to confront uncomfortable truths about our place in the universe. Either intelligent life tends to destroy itself, civilizations universally reject simulation technology, or we're almost certainly living in someone else's creation. Each possibility reshapes how we view reality. The first suggests humanity might be doomed to extinction before reaching our potential. The second implies advanced societies develop wisdom to avoid playing God. The third? Well, that's where things get really interesting. The simulation argument gains weight when you consider our own technological trajectory. We've gone from simple computer games to virtual reality in just decades. At this rate, how long until we can simulate entire worlds? If we're on this path, why wouldn't more advanced civilizations have already achieved it? Bostrom's argument doesn't claim to prove we're in a simulation, but shows how the logic leads to startling conclusions when you follow it through. This connects to an idea called ancestor simulations, the concept that future civilizations might recreate their past. If that's happening, we could be living in someone's historical recreation right now. The implications spiral outward from there. Are our creators themselves simulations? How many layers of reality might exist? And what does this mean for concepts like free will or the nature of consciousness? While the simulation hypothesis remains unproven, it serves as a powerful thought experiment. It challenges our assumptions about what's real and forces us to consider perspectives beyond our everyday experience. Whether you find the argument convincing or not, it raises profound questions about existence that scientists and philosophers continue to wrestle with today. The next question is, what evidence might actually support this extraordinary claim? Consider how far simulation technology has come in just a few decades. The journey from Pong's simple bouncing square to today's photorealistic virtual reality shows a clear trajectory. Each year, game engines produce more convincing environments, characters that behave more naturally, and physics that mirror our world more closely. This progression suggests we're steadily moving towards simulations indistinguishable from reality. If this trend continues, what might we achieve in another 100 years? Or 1,000? Moore's law has driven this advancement, with computing power doubling approximately every 18 months since the 1970s. While this exponential growth faces physical limits, with traditional silicon chips, new technologies are emerging. Quantum computing could provide the next leap forward, potentially offering processing power that makes universe-scale simulations feasible. Neural networks already demonstrate how machines can learn complex patterns and behaviors. Combine these technologies, and the computational requirements for detailed simulations become less daunting. The concept of ancestral simulations adds another layer. Future civilizations might recreate their past to study history or understand their origins. If even one advanced society runs multiple simulations of its ancestors, the number of simulated beings would quickly surpass biological ones. This creates a statistical likelihood that any given conscious experience is more likely to be simulated than organic. Our own efforts in historical recreation, from museum dioramas to period films, show this impulse exists in human culture. Why wouldn't more advanced civilizations take this further? Current virtual reality systems already demonstrate key principles that support simulation theory. Modern VR uses techniques like foveated rendering, where only the area you're directly looking at receives full detail. This optimization mirrors how some theorists suggest a simulated universe might work, only rendering observed areas to conserve processing power. Our own technological solutions to hardware limitations might inadvertently reveal how a simulated reality could function efficiently. Artificial intelligence development provides another parallel. As AI systems grow more sophisticated, they're increasingly capable of generating coherent, context-aware responses and behaviors. In a simulated reality, similar systems could manage the countless background processes and non-player characters that make a world feel alive. The rapid progress in machine learning suggests creating convincing simulated minds might be achievable sooner than we expect. The gap between current technology and full reality simulation appears vast, but history shows how quickly such gaps can close. 50 years ago, the internet didn't exist as we know it. 20 years ago, smartphones were primitive. Technological progress often follows an accelerating curve where breakthroughs build upon each other. Given this pattern, the emergence of convincing simulated realities seems less like science fiction and more like an eventual milestone. This technological perspective doesn't prove we're in a simulation, but it makes the hypothesis more plausible. If humanity continues advancing, we may eventually create simulations indistinguishable from reality ourselves. That realization forces us to consider whether someone might have already reached that point. The same technological principles we're discovering could apply to civilizations far more advanced than ours. Our own limitations in imagining future technologies shouldn't constrain our thinking about what might be possible. People in 1900 couldn't envision modern computing, just as we struggle to imagine technologies 1,000 years from now. The simulation hypothesis asks us to consider that advanced civilizations might have capabilities beyond our current comprehension. What seems like magic or impossibility today might be routine science tomorrow. The most compelling aspect isn't whether we can currently build such simulations, but whether the fundamental concept violates any known physical laws. Nothing in our current understanding of physics prevents the creation of detailed simulations containing conscious beings. This leaves the door open for the possibility that someone, somewhere, has already achieved what we're just beginning to attempt. quantum physics presents some of the strongest potential evidence for the simulation hypothesis. The strange behavior of particles at microscopic scales has baffled scientists for decades, but these oddities might make perfect sense if we're living in a programmed reality. Let's examine how quantum mechanics could reveal our universe's digital foundations. Consider the famous double-slit experiment. When you fire electrons at two small openings, they create an interference pattern like waves. But when scientists set up detectors to observe which slit each electron passes through, the pattern changes to what you'd expect from particles. This suggests that simply observing the system changes its behavior, an effect that aligns with how video games optimize performance. Just as a game engine only renders objects in your field of view, a simulated universe might only fully process the elements being observed to save computational power. This concept extends further with the delayed choice experiment. Researchers found they could wait until after particles had passed through the slits before deciding whether to observe them, and the particles' behavior would change retrospectively. It's as if the universe were adjusting its coding based on whether an observation flag gets set. Such retroactive changes would make sense in a simulated environment where the system can rewrite its own history to maintain consistent physics. Quantum entanglement offers another intriguing clue. When particles become entangled, they remain mysteriously connected regardless of distance. Measuring one instantly affects the other, violating classical physics' speed limit. This immediate correlation could point to an underlying programming relationship, like two variables in code that reference each other's values. The particles don't need to communicate across space because their properties are determined by the same piece of underlying code. Perhaps most remarkably, physicist James Gates discovered something startling when analyzing string theory equations. Embedded within the mathematical descriptions of reality, he found structures identical to error-correcting codes, the same type of digital safeguards that prevent corruption in computer data. This suggests the fundamental fabric of our universe might contain built-in correction mechanisms like any well-designed software, potentially maintaining stability in a digital environment. Even memory phenomena could carry simulation evidence. The Mandela effect, where large groups remember events differently from documented history, has multiple possible explanations. But one intriguing possibility suggests these could be residual traces from when the simulation's code was updated or modified. Just as software updates sometimes leave behind old references or bugs, tweaks to our reality might leave detectable inconsistencies in collective memory. These quantum behaviors and anomalies don't prove we're in a simulation by themselves, but they create a consistent pattern that aligns surprisingly well with what we'd expect from a programmed reality. A simulated universe wouldn't need to render everything at once, would need consistent internal logic like error correction, and would likely show peculiarities at the smallest scales, where the underlying code becomes most apparent. What's particularly compelling is how these quantum effects mirror known computing techniques. The observer effect resembles selective rendering in video games. Entanglement looks like object referencing in programming. Error-correcting codes appear in both computer science and fundamental physics. While conventional explanations exist for these phenomena, their combined weight makes a notable case for the simulation hypothesis when viewed through this lens. Yet these clues still leave us with one massive unanswered question. Consciousness itself, even if the physical world behaves like a simulation, can subjective experience truly emerge from pure information processing? This represents the biggest hurdle for the theory, explaining how code alone could create genuine awareness. Without understanding consciousness fully, we can't determine whether we're players in this simulation or merely programmed characters following predetermined paths. The simulation hypothesis faces its toughest challenge when it comes to consciousness. If we're living in a digital reality, how do we explain subjective experience? Philosopher David Chalmers calls this the hard problem, understanding why and how physical processes in the brain give rise to rich inner experiences. Even if a simulation could perfectly mimic brain activity, we can't prove it would create genuine feelings or awareness. This poses a serious problem for the idea that we're conscious beings in a computer program. Materialist science struggles with this question. Current neuroscience can map brain activity corresponding to certain thoughts or perceptions, but it doesn't explain why we experience anything at all. Some researchers propose consciousness might be fundamental to reality itself, not just a product of complex computation. As one source puts it, if you can't explain consciousness in terms of the existing fundamentals, space, time, mass, charge, then as a matter of logic, you need to expand the list. The natural thing to do is to postulate consciousness itself as something fundamental, a fundamental building block of nature. This view suggests consciousness can't be engineered or simulated because it's a basic property of existence. Digital computation faces particular limitations when it comes to consciousness. Computers operate through syntax, manipulating symbols based on rules, but consciousness involves semantics, meaning, and subjective experience. A perfect simulation of brain activity might replicate behavior without actually creating inner experience. This leads to a disturbing possibility. If consciousness can't be simulated, we might not be conscious at all within this hypothetical simulation, merely sophisticated NPCs, non-player characters, following programmed behaviors without real awareness. Neuroscientist Christoph Koch has argued that consciousness cannot be computed, which would directly contradict the simulation hypothesis if true. This perspective suggests our undeniable experience of consciousness means we can't be living in a digital simulation. However, an advanced civilization might understand consciousness in ways we don't yet grasp. Perhaps they've discovered methods beyond digital computation to create or transfer conscious experience. This remains speculative, but it leaves the door open to the simulation argument despite the consciousness challenge. The binding problem presents another hurdle. Our brains integrate countless sensory inputs, memories, and cognitive processes into a unified conscious experience. Science hasn't fully explained how this integration occurs, making it difficult to imagine how a simulation could replicate it. If we can't understand how biological brains create unified consciousness, we can't say whether simulated brains could achieve the same result. This doesn't disprove simulation theory, but it shows major gaps in our understanding that affect the argument's plausibility. What makes these questions particularly frustrating is that consciousness is the one thing we can be absolutely certain exists, our direct experience of reality, yet it's the hardest to explain or replicate. Even if we accept that future civilizations could build simulations indistinguishable from reality externally, the internal experience remains unverifiable. You could be the only conscious being in what appears to be a simulated universe full of convincing but non-conscious entities. This solipsistic possibility can't be ruled out theoretically. The consciousness problem might actually help refine the simulation argument rather than disprove it. If consciousness is fundamental, maybe simulations tap into this fundamental property in ways we don't understand. Some interpretations of quantum mechanics suggest consciousness plays a role in shaping reality at small scales, a notion that aligns surprisingly well with simulation ideas, where observation determines what gets rendered. This remains highly speculative, but shows the conversation is evolving. Ultimately, consciousness represents the biggest unanswered question for both neuroscience and simulation theory. Until we understand what creates subjective experience, we can't determine whether it could arise in an artificial system. This keeps the simulation hypothesis in an interesting limbo, neither provable nor disprovable based on current knowledge. The debate forces us to confront how much we still don't understand about minds, reality, and existence itself. Moving beyond the consciousness question, we have to ask, if we accept the simulation premise, how should that change how we live our daily lives? If we're living in a simulated reality, how should that change how we live? The answer might surprise you. Perhaps not at all. Some billionaires have reportedly funded research to try breaking out of the simulation, treating it like a digital prison to escape. But others argue that even if this world is constructed, our experiences still hold real value. The emotions you feel, the connections you make, they're undeniably significant to you, regardless of their origin. This raises profound questions about what makes something real in the first place. Consider how we already treat virtual experiences. When you feel joy from playing a game or watching a movie, those emotions are genuine, even though the stimulus wasn't physically real. Similarly, if we're in a simulation, our happiness, pain, love, and curiosity would still be authentic experiences. The New Yorker reported that some tech leaders take this idea seriously enough to fund scientific attempts to interact with or transcend the simulation. This shows how the hypothesis moves beyond philosophy into practical considerations about how we spend our time and resources. Religious traditions have grappled with similar concepts for millennia. Hinduism's concept of Maya suggests the physical world is an illusion obscuring a deeper reality. Buddhist teachings describe reality as impermanent and constructed by perception. These parallels suggest humans have long suspected our experience might not reflect ultimate truth. The simulation hypothesis just updates this ancient intuition with digital language. Whether framed as spiritual illusion or computer code, the core idea remains: reality might not be what it seems. This perspective can actually enhance life's meaning rather than diminish it. If our world is simulated, that makes consciousness even more remarkable. The fact that such rich experience can emerge from information processing, it suggests the universe, whether natural or artificial, has properties allowing for subjective experience. Your morning coffee tastes good, sunsets remain beautiful, and human connection feels meaningful regardless of whether neurons are biological or digital. The value comes from the experience itself, not its substrate. The simulation argument also encourages us to question assumptions about what matters. If this is all constructed, why do we prioritize certain things over others? Why chase money or status in what might be an elaborate game? At the same time, it doesn't justify reckless behavior. Pain still hurts, consequences still matter within the simulation's rules. But it might shift our focus toward experiences over possessions, relationships over achievements. Some worry that if nothing is fundamentally real, ethics become meaningless. But this ignores that moral experiences would still be real to us. Just because something is simulated doesn't make it unimportant. Think of how seriously we take fictional stories that move us. The rules of our reality, whether programmed or natural, create real consequences for ourselves and others. Cruelty would still cause suffering, kindness would still bring joy, regardless of reality's ultimate nature. Interestingly, the hypothesis might make life more precious, not less. If we're in a simulation, our existence represents someone's intentional act of creation. That suggests purpose behind our reality, even if we don't understand it. Alternatively, if we're in base reality, that makes us extraordinarily lucky to exist in the original universe. Either way, it fosters appreciation for the improbable gift of consciousness. The simulation perspective also changes how we view technology. As we develop more immersive virtual worlds, we might be recreating the same process that created our reality. This creates an interesting symmetry. If we're simulated beings building simulations, it suggests consciousness might be able to exist on multiple levels. Our digital creations could someday contain their own conscious beings, continuing the cycle. Ultimately, whether we're in a simulation or not, the practical implications come down to how we choose to live. The hypothesis serves as a reminder that reality is more mysterious than we typically assume. It encourages curiosity about existence while affirming the value of our present experience. Your life matters because you experience it. That truth holds regardless of what's running the universe in the background. Before we conclude, let's consider what might be the most mind-bending implication of all: the possibility that our creators are themselves simulations in an endless chain of realities. The concept of nested realities takes the simulation hypothesis to its most mind-bending conclusion. If we're living in a simulation, what about the beings who created ours? They could themselves be simulations within a higher-level reality. This creates a potential infinite regress, simulations within simulations, with no clear original universe. Each layer might contain conscious beings running their own simulations, creating a fractal structure of existence that challenges our notion of what real means. The computational requirements for such nested simulations would be staggering. Some theorists suggest advanced civilizations might harness black holes as processing power. The intense gravitational fields could provide the energy needed to simulate entire universes. Others propose megastructures like Dyson spheres, hypothetical constructs that capture a star's entire energy output. These could power simulations on cosmic scales. The energy demands help explain why we might only see parts of reality rendered when observed. It's an optimization strategy for an unimaginably complex system. This raises profound questions about the nature of base reality. If simulations can contain simulations indefinitely, does an original non-simulated universe even exist? The concept becomes increasingly abstract the deeper we go. Some philosophers argue there might be no top level, just an endless chain of creators and creations. Others suggest the highest reality could be so fundamentally different from ours that we can't comprehend its nature. The Hindu concept of Maya describes a similar idea: our perceived reality as an illusion veiling a deeper truth. Ancient cultures often explored these concepts through mythology and philosophy. Indigenous traditions frequently describe dreamlike layers of existence. The Australian Aboriginal concept of the dreamtime presents reality as both physical and metaphysical. Plato's allegory of the cave depicts humans seeing only shadows of true forms. These historical parallels show humanity has long questioned whether our world represents ultimate reality or something more complex. The practical implications of nested realities are staggering. If true, our attempts to simulate consciousness could create new layers of existence. This suggests consciousness might propagate through simulations indefinitely. Some researchers propose that quantum phenomena could provide processing power for these nested worlds. Quantum superposition and entanglement might allow single particles to perform multiple calculations simultaneously, enabling universe-scale simulations within finite energy constraints. This perspective changes how we view our place in existence. We might be middle layers in an infinite stack, both creators and creations. Our simulated descendants could one day become gods to their own simulations, continuing the cycle. The ethical dimensions become complex. Should we create simulated beings, knowing they might suffer? Or does the potential for infinite conscious experience justify the process? These questions mirror religious debates about why a benevolent God would allow pain. The energy requirements for nested simulations suggest observable cosmic phenomena might be evidence. Unexplained energy signatures in space could indicate computation occurring at scales we can't comprehend. Some theorists propose that dark matter and dark energy might relate to simulation processes. The universe's apparent fine-tuning for life could reflect intentional parameters set by creators. These ideas remain speculative, but show how the hypothesis interacts with cutting-edge physics. Ultimately, the concept of nested realities makes the simulation hypothesis both more compelling and more unsettling. It resolves the who created the creators problem, but at the cost of infinite regression. Whether we're in one simulation or 1,000, the core questions remain: what is real, what is our purpose, and how should we live, knowing reality might be layered like an onion? These questions don't have easy answers, but they push us to think more deeply about existence than ever before. The possibility of infinite layers suggests we may never find definitive answers about reality's nature, but the search itself changes how we view our world. Whether we're base reality or simulation, the experience of consciousness remains equally profound. This perspective can be liberating. Our struggles and joys matter, regardless of their ultimate context. The nested reality idea ultimately serves as a mirror, reflecting back our deepest questions about meaning in an uncertain universe. Does it fundamentally matter whether we're living in a simulation or not? This question cuts to the heart of why the simulation hypothesis fascinates us. Some philosophers argue that since we can't prove or disprove it, the idea has no practical value. Others counter that it's among the most important questions we can ask about existence. The truth likely lies somewhere between these extremes. The value isn't in the answer, but in how the question reached. The unfalsifiable nature of the simulation hypothesis presents an interesting paradox. Normally in science, a theory must be testable to be meaningful, but this idea challenges that framework by suggesting reality itself might be constructed. This doesn't make the question meaningless, it simply moves it into philosophical territory where different rules apply. The hypothesis forces us to examine our assumptions about what real means and how we know anything at all. This uncertainty serves an important purpose. It keeps us questioning and curious, pushing the boundaries of both science and philosophy. The search for answers drives progress even when definitive proof remains elusive. Think about how quantum physics developed. Scientists had to accept strange, counterintuitive ideas because the evidence demanded it. The simulation hypothesis might follow a similar path, challenging our concepts of reality until new discoveries either support or undermine it. Our daily experiences remain vivid and meaningful regardless of reality's ultimate nature. Pain still hurts, joy still uplifts, and human connections still matter. As one perspective notes, a conscious simulated mind would be a real mind with real experiences. This suggests that even if we're in a simulation, our lives hold authentic value. The emotions we feel and the choices we make would still carry weight within whatever framework we inhabit. The simulation argument also changes how we view intelligence's role in the universe. If advanced civilizations commonly create simulations, then reality might contain nested layers of conscious experience. This perspective shifts our focus from whether the world is real to understanding how different levels of reality might interact. It suggests that intelligence doesn't just discover reality, it may actively shape and extend it through creation. Some worry that accepting we might be in a simulation could make life feel meaningless. But the opposite may be true. If our reality is constructed, that makes consciousness even more remarkable. The fact that such rich experience can emerge from information processing. It suggests the universe, whether natural or artificial, contains properties that allow for subjective experience. Your morning coffee still tastes good, and sunsets remain beautiful regardless of reality's substrate. The practical implications become most apparent in how we approach knowledge and existence. The hypothesis encourages intellectual humility, recognizing how much we don't understand about reality's fundamental nature. It also fosters curiosity about the boundaries between physics, computation, and consciousness. These questions drive innovation in fields from quantum computing to artificial intelligence. At its core, the simulation hypothesis serves as a mirror for human curiosity. It reflects our deep desire to understand our place in existence, whether that existence is fundamental or constructed. The theory doesn't provide easy answers, but it asks profound questions that stretch our thinking. In doing so, it reveals how reality, whatever its nature, is far stranger and more wonderful than we typically assume. The value lies not in proving or disproving the idea, but in how it changes our perspective. Whether we're base reality or simulation, the experience of consciousness remains equally remarkable. This realization can make life feel more precious, not less. It suggests that meaning comes from our experiences themselves, not from whatever underlying reality makes those experiences possible. As we consider these ideas, we're left with a simple but powerful truth. Your consciousness is having a genuine experience right now. That fact remains unchanged, whether you're biological or digital, in base reality or simulation. The mystery of existence continues to unfold, inviting us to keep exploring while appreciating the present moment. This balanced perspective, questioning reality while valuing experience, may be the hypothesis's most important gift. The simulation hypothesis leaves us with two clear takeaways. First, reality, whether base or simulated, holds far more mystery than our everyday assumptions suggest. Nick Bostrom's argument shows how much we still don't understand about existence. Second, whatever reality's true nature, your experiences matter just as much. A simulated mind would still be a real mind, with real experiences. As you finish watching this, consider this simple fact. Your consciousness is registering these words right now. That experience remains unchanged, whether it's biological or digital. The wonder isn't in solving the mystery, but in recognizing the extraordinary fact that you're here to ponder it at all.